Quarter 1, Week 4. Materials and their uses, physical change and chemical change. Matatag curriculum, bansang makabata, batang makabansa, with me, Teacher KMT. Good day, kids! Today, we will learn about materials and their uses, physical change and chemical change. Here are the possible objectives for today's lesson. Number 1. Describe changes in matter that involve physical change and chemical change. Number 2. Investigate to show how changes in properties of materials occur when exposed to very high or very low temperatures. Number 3. Cite situations wherein phase change is beneficial. Short review. Instructions. Recall your prior knowledge of the characteristics of the three states of matter: solid, liquid, and gas. Complete the table below by describing the characteristics of solids, liquids, and gases. Give examples for each state. Let's start answering. States of matter. First, solid. Characteristics. Solids hold their shape. They do not flow and do not take the shape of their containers. Examples: papers, coins, books, and pencils. Second, liquid. Characteristics. Liquids are objects that flow. They take the shape of the containers that hold them and fill the container starting from the bottom. They do not float, and they can be held in a container even with an open lid. Examples: water, oil, and alcohol. Third, gas. Gases take the shape of their containers. When placed in a container with an open lid, gas particles will go out or escape the container. Gases are usually light and can float around in space. Many gases cannot be seen. Examples: the air that we breathe. Lesson purpose. Matter undergoes various changes when exposed to changes in temperature, which can be classified as either physical or chemical. In the next phase of the lesson, you will be able to know and understand how these changes in matter happen. It could be a change in its internal structure or physical appearance. It may also result in the formation of new materials when they are mixed. Unlocking content area vocabulary. Unscramble word game. Below are scrambled words. Rearrange the letters to create the correct form. Let's start. Meaning: it is to make or become different. Unscrambled word number 1. What is the correct answer? Good job! The correct answer is change. Meaning, it is a measure of how hot or cold something is. Unscrambled word number 2. What is the correct answer? Great! Temperature. Meaning, it is a type of food with a limited shelf life if it's not refrigerated. Unscrambled word number 3. What is the correct answer? Good job! Perishable. To continue, meaning it is a process in which one or more substances, the reactants, are converted to one or more different substances, the products. Unscrambled word number 4. What is the correct answer? Very good! The correct answer is chemical reaction. Meaning, it is the chemical reaction that occurs between substances when materials burn. Unscrambled word number 4. What is the correct answer? Awesome! Combustion. First lesson, physical change. One of the changes that can happen in matter is a state change. A solid object can turn into a liquid or a gas. A liquid can turn into a solid or a gas. Last, gases can turn into liquids or solids. When exposed to very high or very low temperatures, these changes happen to materials. A physical change is when something changes its shape, size, or state, but it stays the same substance. Examples are melting ice, boiling water, breaking glass, chopping wood, folding paper, and breaking egg. Observe the changes in the ice cube as it melts. As the temperature increases, the ice absorbs heat energy from its surroundings, causing its molecules to gain energy and move more freely, thus changing from a solid to a liquid. The same substance, water, can exist in different states of matter depending on the temperature. This applies not just to water but to many other substances. Can you answer? Number 1. What is the current state of the ice cube? Number 2. Can you describe the properties of the ice cube? Example, solid, cold to touch. Number 3. What changes do you observe as the ice cube are heated? Number 4. What is happening to the ice cube as they start to melt? Number 5. Can you describe any changes in the appearance or texture of the ice cube? Work example. What is melting? In the video, the ice cube melted when exposed to high temperatures and turned into liquid or water. Melting is a process where a solid turns into a liquid when it gets warm enough. When something melts, it becomes soft and turns into a liquid. For example, when ice cream melts, it becomes a liquid instead of being hard like ice. Examples of melting. Ice melting. One common example of melting is when ice cubes are left outside on a warm day. As the sun shines on them or the temperature gets warmer, the ice cubes start to melt and turn into water. Chocolate melting. Another example is when you heat chocolate in a microwave or over a stove. The solid chocolate turns into a liquid, making it easier to spread or use for making desserts like chocolate-covered strawberries. Candle wax melting. When you light a candle, the heat from the flame melts the wax. The melted wax then drips down the candle, creating a pool of liquid wax that fuels the flame. Real-life applications or uses. Cooking. Melting is used in cooking to transform solid ingredients into liquids. For example, butter is melted before adding it to cake batter, or melted cheese is used as a topping for nachos. Making popsicles. Melting is involved in making popsicles. You pour liquid juice or flavored water into molds and then freeze them. When you take them out of the freezer and let them sit, the popsicle starts to melt, turning back into liquid. Recycling. Melting is used to recycle metals like aluminum and steel. Scrap metal is melted down at high temperatures to make new products like aluminum cans or steel beams, instead of throwing it away. Art and crafts. Melting can be used in art and crafts projects. For example, crayons can be melted and poured into molds to make new crayons with different shapes or colors. What is evaporation? In the video earlier, if the melted ice cubes which have turned into liquid are continually exposed to high temperatures, the liquid will eventually turn into gas. Evaporation is when the liquid turns into a gas. This happens when the liquid gets warm enough and its molecules move so fast that they escape into the air as vapor. You can think of it like tiny invisible water particles flying away from a puddle, a cup of water, or even wet clothes when they are left out to dry. This is when the liquid eventually turns into gas. Examples of evaporation. Drying clothes. After washing your clothes, you hang them outside to dry. As the sun shines on them and the air around them gets warm, the water on the clothes evaporates and they become dry. Puddles disappearing. After it rains, you might notice that puddles on the ground disappear even if it's not sunny. This happens because the water in the puddles slowly evaporates into the air. Steam from boiling water. When you heat water on a stove to make tea or cook pasta, steam rises from the pot. This steam is water vapor, formed because the water is evaporating. Real-life applications or uses. Swimming pool evaporation. Have you ever noticed that a swimming pool gets lower over time even if nobody takes water out? This is because water evaporates from the surface of the pool, especially on hot days. That's why sometimes we need to add more water to keep the pool full. Drying wet surfaces. If you spill water on the kitchen counter or the bathroom floor, you can wipe it off with a towel. But what happens if you leave it there? Eventually, the water evaporates and the surface becomes dry again. Water cycle. Evaporation is a crucial part of the water cycle. When the sun heats up bodies of water like oceans, rivers, and lakes, water evaporates into the air. This water vapor rises, cools down, and forms clouds. Later, when the clouds get heavy with water, it falls back to the ground as rain, snow, or hail. Making salt. Ever heard of sea salt? It's made by evaporating seawater. When seawater is left out in the sun, the water evaporates, leaving behind salt crystals.
These crystals are collected and cleaned to make the salt we use in cooking.
What is freezing? It occurs when a liquid turns into a solid when it gets cold enough. Imagine water turning into ice when it's left in the freezer or outside on a cold winter day. The cold slows down the molecules in the liquid, making them stick together and form a solid. Examples of freezing. Making ice cubes. One common example of freezing is making ice cubes. You pour water into an ice cube tray and put it in the freezer. The water freezes and turns into solid ice cubes as the water gets cold. Freezing popsicles. When you make popsicles at home, you pour juice or flavored water into molds and put them in the freezer. Over time, the liquid freezes, turning into tasty frozen treats. Ice cream. Have you ever seen an ice cream machine at an ice cream shop? It works by freezing a mixture of cream, sugar, and flavors while stirring it. This makes creamy ice cream that you can enjoy on a hot day. Real-life applications or uses. Preserving food. Freezing is a great way to keep food fresh for longer. You can freeze fruits, vegetables, meat, and leftovers to prevent them from spoiling. This way, you can enjoy your favorite foods even if you can't eat them right away. Keeping cool. Ice and frozen treats are perfect for keeping cool on a hot day. Whether you're drinking a cold glass of lemonade with ice cubes or enjoying a frozen dessert like ice cream or popsicles, freezing helps us stay refreshed when it's hot outside. Transporting perishable goods. In places where it's hard to keep food fresh, like during long journeys or in remote areas, freezing is used to preserve perishable goods. Foods like meat, fish, and vegetables are frozen before being transported to keep them from spoiling. Making frozen treats. Freezing is essential for making all kinds of delicious frozen treats, such as ice cream, sorbet, frozen yogurt, and gelato. These treats are enjoyed by people all over the world, especially on hot summer days. Lesson activity to be guided by your actual teacher. Second lesson, chemical change. A chemical change happens when a substance transforms into a completely different substance with new properties. This process usually involves a chemical reaction. A chemical reaction forms new products: combustion, rotting, rusting, digestion. Combustion. When something burns like wood or gasoline, it reacts with oxygen in the air to produce new substances such as carbon dioxide, water vapor, and ash. The original material is transformed into entirely different substances. Rotting. When food rots, it undergoes decomposition due to bacteria and fungi. These microorganisms break down the food into new substances such as gases, liquids, and simpler organic compounds. The original food is no longer the same. Rusting. When iron or steel rusts, it reacts with oxygen and moisture in the air to form iron oxide or rust. This is a new substance with different properties from the original iron or steel. Digestion. When you eat food, your body breaks it down into simpler substances through chemical reactions in your stomach and intestines. These reactions produce new substances that your body can absorb and use for energy, growth, and repair. Work example. To be guided by your actual teacher. These examples help demonstrate how high temperatures can lead to chemical changes in different substances, resulting in new materials or products with altered properties. Benefits of chemical changes. Number 1. Cooking food. Chemical changes occur when we cook food, turning raw ingredients into tasty meals. For example, when we bake cookies or grill burgers, the heat causes chemical reactions that make the food taste delicious and safe to eat. Number 2. Making new materials. Chemical changes help us create new materials with useful properties. For instance, baking soda and vinegar react to produce carbon dioxide gas, which makes baked goods rise and become fluffy. Number 3. Producing energy. Chemical changes are essential for producing energy. When we burn wood or fossil fuels like coal or natural gas, chemical reactions release heat and light energy that we use for heating our homes, cooking food, and generating electricity. Harmful effects of chemical changes. Number 1. Pollution. Some chemical changes can pollute the air, water, and soil. For example, burning fossil fuels for energy releases pollutants like carbon dioxide and sulfur dioxide, which contribute to climate change and air pollution. Number 2. Toxic substances. Certain chemical changes can produce toxic substances that harm living things. For instance, when plastic is burned, harmful chemicals are released into the air that can cause health problems if inhaled. Number 3, damage to the environment. Chemical changes can cause damage to the environment and ecosystems. For example, chemicals from factories or farms that get into rivers and oceans can harm fish and other aquatic life, disrupting the balance of ecosystems. Lesson activity to be guided by your actual teacher. Learners' takeaways to be guided by your actual teacher. Reflection on learning to be guided by your actual teacher. Evaluating learning. Direction. Read each question carefully. Identify the letter of the correct answer. Number 1. Which of the following is an example of physical change? A. Burning wood. B. Rusting iron. C. Melting ice cream. D. Baking a cake. What is the correct answer? Good job! The correct answer is letter C. Melting ice cream. Number 2. What happens when you tear a piece of paper into small pieces? A. A chemical change occurs. B. The paper undergoes evaporation. C. The paper undergoes a physical change. D. The paper undergoes sublimation. What is the correct answer? Correct! Letter C. The paper undergoes a physical change. Number 3. Which of the following is an example of chemical change? A. Cutting vegetables. B. Melting butter. C. Mixing baking soda and vinegar. D. Freezing water. What is the correct answer? Good job! The correct answer is letter C. Mixing baking soda and vinegar. Number 4. Sarah was cooking scrambled eggs for breakfast. She cracked some eggs into a hot frying pan and stirred them until they were cooked. What type of change did the eggs undergo during cooking? A. Physical change. B. Chemical change. C. No change occurred. D. Both physical and chemical changes. What is the correct answer? Awesome! The correct answer is letter B. Chemical change. Number 5. Timmy mixed some sugar into his glass of water until it's dissolved completely. What type of change occurred when the sugar dissolved in the water? A. Physical change. B. Chemical change. C. No change occurred. D. Both physical and chemical changes. What is the correct answer? Great! The correct answer is letter A. Physical change. Number 6. Which of the following is an example of physical change involving a change of state? A. Rust forming on an iron nail. B. Paper burning and turning into ashes. C. Ice melting into water. D. Milk spoiling and curdling. What is the correct answer? Good job! The correct answer is letter C. Ice melting into water. Number 7. Maria was baking cookies in the oven. As the cookies were baked, they turned golden brown and became firm. What type of change occurred to the cookies during baking? A. Physical change. B. Chemical change. C. No change occurred. D. Both physical and chemical changes. What is the correct answer? Good job! The correct answer is letter B. Chemical change. Number 8. Alex lit a candle and observed as the wax melted and formed a pool of liquid around the wick. What type of change occurred to the wax during burning? A. Physical change. B. Chemical change. C. No change occurred. D. Both physical and chemical changes. What is the correct answer? Great! The correct answer is letter D. Both physical and chemical changes. Here's why. Physical change. The wax melting around the wick is a physical change because it changes from solid to liquid without altering its chemical composition. Chemical change. The burning of the wick and wax produces new substances like carbon dioxide and water vapor, indicating a chemical change. To continue, number 9. Jason was cleaning his bicycle after a ride. He noticed that the metal parts were starting to rust. Why is it important for Jason to prevent rust from forming on his bicycle? A. To make his bicycle look shiny and new. B. To avoid damaging the metal parts of his bicycle. C. To impress his friends with his well-maintained bicycle. D. To win a prize for the best-looking bicycle. What is the correct answer? Good job! The correct answer is letter B. To avoid damaging the metal parts of his bicycle. Number 10. Anna was planning to cook dinner for her family. She needed to know whether cooking chicken in the oven would result in a physical or chemical change. Why is this important for Anna to consider? A. So she can impress her family with her cooking skills. B. So she can choose the best cooking method for the chicken. C. So she can avoid making a mess in the kitchen. D. So she can win a cooking competition. What is the correct answer?
Correct!
Letter B. So she can choose the best cooking method for the chicken. Well done, kids! Homework. This is optional to be guided by your actual teacher. What have we learned today? Today, we learn about that a physical change is when something changes its shape, size, or state, but it stays the same substance. We also learn that a chemical change happens when a substance transforms into a completely different substance with new properties. This process usually involves a chemical reaction. A chemical reaction forms new products: combustion, rotting, rusting, and digestion. Kids, thank you for listening. I hope you have learned. Please do not forget to click the like, share, and subscribe.